2. This week is about the Argand diagram, a fancy way of pretty much saying the Cartesian plane for complex numbers. So the Argand diagram is the Cartesian plane for complex numbers. For complex numbers, we usually had coordinates x and y. For our Argand diagram, what do you think they're going to be? The real part of z and the imaginary part of z. So complex number z equals a plus bi is usually represented by a point with coordinates x and y in the xy plane. The xy plane, when used to represent complex numbers in this way, is called the Argand diagram. In the Argand diagram, real numbers are represented by points on the x-axis, which is called the real axis. Purely imaginary numbers are represented by points on the y-axis, which is called the imaginary axis. That's full stop there. Any questions at this stage from what you've read? Anything you don't understand? Give you a second to absorb that. Nope, makes sense. Scrolling down. For example, in the following Argand diagram, let's draw it up. Z1 equals 2 plus 3i. Z1 equals 2 plus 3i. Well, there's 1, there's 2, because technically think of it like your x. Remember, these are your real parts. This is your imaginary parts. So 1, 2, and then going up 3. 1, 2, 3. Right there. That becomes like your y. And that is point Z1. Note the different size. Usually when we're representing something, we write them in capitals. That's just, I guess, convention. Any questions there? -2 plus 4i, -1, -2 is there, and then go up 4i. So 1, 2, 3, 4. That would be Z2. Z3 is 2i. Can somebody tell me where I would draw that? Z3 equals 2i.
0, 2.
Yeah, right. It's just there. X is 0. There is no real part. So that would be Z3. And then Z4 is -3, which means there's no imaginary part, which is right. Yeah, that's Z4. Any questions? Julia, can you see why I was trying to say 2 and 3 must be real numbers? Because they are, as you can see, these are real numbers. These are real numbers. But the I is just there to represent that that component there is meant to be your imaginary part. And that component there is meant to be your real part. Does that make sense?
Yes.
Otherwise, what you had before, I mean, up to today, let's say, the way you've plotted these, it's looked like this. And that, again, tells you this is your X, this is your Y. So we need a similar system for complex numbers. And it's exactly the I. That I is trying to tell you that bit there is your imaginary part, whereas that bit there is your real part. So that bit there is your Y part, that bit there is your X part. All good?
Mm-hmm.
Very good. That was easy, but important, but easy. All right. Next bit. Polar form of complex numbers. Okay. Polar form of complex numbers. Polar form, let's write them a few different ways. Polar form, mod arg form, and then And then we'll also write, we'll add here, now in exponential. Okay, I'll leave that so I don't forget to do that. All right, polar form of complex numbers, or sometimes called mod-arg form. So a fancy way, but it's just a different way of writing my z. So in the figure, the point P represents the complex number z equals a plus bi. So let's just draw that up. There's a, there's b, and there's z. Right? Oh, sorry, the point P represents. So that's the point P. There it is. Let OP equal to R. So imagine that was R and that's O. Theta be the angle which OP makes with the positive x-axis. So let that be theta. The angle being measured from the positive x-axis and is positive if the direction is counterclockwise. So we're going this way and that's positive, similar to SOHCAHTOA, right? Then, can somebody tell me a way of finding this distance for A? So another way of finding A. Sorry? No. Well, if I close this up, I didn't need to say that. It's something that you guys need to learn to do, not for this topic, but for other topics. Like you're going to have, an exam on multiple topics. You got to learn to put things all together. That's why I probably, try to make you guys identify these little bits and pieces. But that's okay. Can you guys find A now? If I drew what I drew. Can you find A? You won't have an actual answer for it, by the way.
Oh, so just Pythagoras.
You can't use Pythagoras because you don't have this one. But you're very close. What's the other one?
Sine.
Yeah, SOHCAHTOA. So yeah, something like that. Hold on now. So if I'm trying to find this length, we're going to do cosine, right? We're going to do cos theta equals A on R, which means A becomes R cos theta. And if you do the same thing, sine theta equals B on R. Therefore, B equals R sine theta. Does that make sense? You don't need to know those for this course, but you do need to do that for, other topics, and it's important to see where they're coming from. Now, we're going to keep going so you don't get confused, because that was a simple task. Now, what you're able to see is R is also equal to Pythagoras, square root of A squared plus B squared, right? R is equal to square root of A squared plus B squared. We all know that. And if we divide these two, so if we get B divided by A, what do you end up with? You end up with R sine theta on R cos theta. In fact, you end up with B on A equals to tan theta. That is what you do need to know now. So R equals square root A squared plus B squared. Tan theta equals B on A. So you don't need to know where it comes from unless you would like to. It's always good to know, the proofs of things. But that's your formula you want to know to be able to convert to polar form or mod-arg form. All right, so we've got R equals Pythagoras, and then tan theta equals B on A. Hence, Z equals R bracket cos theta plus I sine theta. Let's see if that's true. What does Z equal to originally? What did Z equal to? Right up there.
A plus bi,
But what does A equal to now?
r cos theta,
Plus, what does B equal to now?
r sine theta,
And then what can you factorize out?
r,
And then you're left with cos theta plus I sine theta. We very rarely would ever write I at the end of a theta. So we always put it at the beginning, just so you guys know. But anyways, there it is. So hence you get Z equals to R cos theta plus I sine theta. Yes, you also need to memorize that. That is polar form. So this with the thetas is polar form. So you can write it in Cartesian form or polar form. Now, just to simplify it, you could also write it as r cis theta. Can anyone see where this comes from? Maybe other than Queenie. Can anyone see where cis theta is coming from? R.
Cos imaginary sign.
Yeah, you're right. So it's just an acronym because it's annoying to write. So we simplify it by going C is for the cos, I is obviously for the imaginary, S is for the sine. So instead of writing this, we probably will be writing more R cis theta, R cis theta, R cis theta. All right, good. Note, now we can deduce Z equals A plus BI is also the same as R equals to R cos theta plus I sine theta, which is R cis theta. That is just the proof of it all, right? What you guys need to know is that in red, and pretty much you write it as that in yellow. Any questions at this stage? Because there's a lot of proofs there. Any questions? Good. Caleb, let's just confirm. You're happy with everything so far?
Yep.
So R equals and tan theta equals B on A. All right. Scroll down. The above form of the complex number Z is called the polar form. I just said that. R is denoted sometimes by the modulus of Z. So that looks like to you guys absolute value of Z, but it's not. It's called modulus. That's the word we use. It is absolute value, obviously, but it's not. We don't say absolute value of Z. We say the modulus of Z, which is called the modulus of Z. So it's just the distance. That's just a fancy way of saying distance of Z. How would you have found that distance of your Z? You obviously would have done Pythagoras' theorem, hopefully, before even this course. If I gave you an X and a Y, let's go up here. If I said, hey, go find me, that length, like in year 8, you would have just done 2 squared plus 3 squared, and then square rooted it. Right, Rav?
yeah.
In year 8, don't forget that. You would have done that in year 8. You're in extension 2 and you're doing the same thing still. It's just that it's fancier way of writing them now. But you're still doing Pythagoras. Try not to think, oh my God, it's extension 2. It's just because all this terminology, once you wrap your head around the terminology, you're just doing year 8. Okay, good, back to it. Hold on. So one more time. The above form of the complex number Z is called the polar form. R. The R is sometimes denoted by modulus of Z, which is called the modulus of Z. Theta. Theta is sometimes denoted by the argument of Z, arg Z. So if the question asks for modulus and argument, then you're really just finding R and tan theta. So that's why I wrote up here polar form or sometimes mod arg form. Modulus. Which one's the modulus? R. Which one's the argument? Your theta. Mod arg form. Any questions? Note that the argument theta is measured. I'm going to get into that point in a second. So let's pause this recording.